Welcome back. Time for learning some science. This time we are going to learn simple machines and friction. And I'm calling this segment Introduction to Simple Machines. Simple machines is in a theme called matter and energy. Matter and energy. So there's some background information that you must have before we start on simple machines and friction. Matter, you need to be able to define the term matter. Matter is anything that has mass and volume. Go back and revise your P5 work. Energy. Energy is the ability to do work. Energy is the ability to do work. You need to be able to identify some forms of energy, at least 4 forms of energy. We have heat energy, you did in P5, sound energy, electric energy, and light energy. Then the other forms of energy, still we have mechanical energy, you studied that in P5, mechanical energy and chemical energy. Those are examples of forms of energy. Like I said, energy is the ability to do work. What is work? Work is the product of force and distance in the direction of force. Or we can say work is when the force applied on an object is moved through a distance. So, since we talked of force, you need to be able to identify some forces, some examples of forces. We shall begin by asking ourselves, what is a force? Still, that is your P5 work. A force is a pull or a push. Another person could say a force is a pull or a push exerted on an object. Another person can say a force is a pulling or a pushing effect. Then the last one, which is a bit complex, we can say a force is the effect that can change a body's steady state of uniform motion or rest. I advise you go with the first ones. So we need to be able to give some examples of forces and define them. Examples of forces, we have magnetism. Magnetism is the force that enables a magnet to attract other magnetic materials. Friction is the force that opposes motion between 2 or more surfaces in contact. We have other forces like cohesion and adhesion. Cohesion is the force of attraction between molecules of the same kind, while adhesion is the force of attraction between molecules of different kinds. There's another force called inertia. Inertia is the force that keeps an object in its steady state of uniform motion or rest. For example, when you're in a car that is speeding, you will be speeding with the car. But when the driver applies instant brakes, you tend to continue moving. That is inertia in motion. If there isn't anything stopping you, you might end up hitting the windscreen. Then we have inertia at rest. If someone pushes you all of a sudden when you're resting or when you're standing, there's that force that tends to keep you standing, which might cause you problems. If you're seated on a border that is not moving, then all of a sudden the man starts, you might topple over because you're being acted upon by that force called inertia at rest. We have got other forces like upthrust or buoyancy. Upthrust or buoyancy is the force that makes objects weigh less when they are immersed in water. Then other forces, we have got weight. Weight is gravitational force acting on matter, or we can say weight is the force exerted on an object due to the pull of gravity. So don't tell us weight is the heaviness or lightness of an object. That is kind of P4. Then there are very many other forces like surface tension, centrifugal, and very many other forces that may not be for our level now. So that is a brief introduction to the introduction to simple machines. Now, this is what we are going to do. We are going to define machines. We are going to group the machines. We are going to classify the machines. And then we shall see the characteristics of each group of machines. So, what is a machine? A machine is a device that simplifies man's work, or a device that simplifies work. It is a device that makes work easy. It is a device to which force is applied to simplify work. That is a machine. Machines are broadly grouped into two: simple machines and complex machines. Simple machines and complex machines. So, what are simple machines? Simple machines are made of few parts and don't require training to use. Simple machines are made of few parts and they don't require training to use. Then complex machines are made, a complex machine is made of two or more simple machines and it requires training to use. Or we can say it is a part made of many components. It is a machine made of many components and it requires training to use. So machines are broadly grouped into simple machines and complex machines. Simple machines, we have got these 6 groups. We have these 6 groups, and for each group we shall give it a segment. Make sure you look for those videos. Then let's look at examples of complex machines. Examples of complex machines are, for example, a car or vehicles. Vehicles are complex machines because vehicles have a lot of levers on them. They have some planes on them. They have screws on them. They have a lot of wheel and axle on them. So vehicles are complex machine. A bicycle, a motorcycle, a sewing machine is a complex machine. A computer is a complex machine. An aeroplane is a complex machine. So those that are made of many components and require training to use are called complex machines. Then simple machines, all those different tools under these qualify to be called simple machines. Why do they qualify to be called simple machines? This is because they are made of few parts and they don't require training to use. Then simple machines are broadly grouped into levers, inclined planes, pulleys, wedges, screws. We also have wheel and axle. Those are the groups of simple machines. Before we continue, we also need to discuss how machines simplify work. How do machines simplify work? There are 3 major responses here. 1, they make work get done faster. Machines make work get done faster. You can say they increase the speed at which work is done. If someone is using a car and you're walking on foot, they will reach before you. The machine has simplified work for them. Then 2, they reduce on the effort applied. They reduce on the effort applied. Some machines reduce on the effort applied, as we shall see. Most of these, the levers, the pulleys, inclined planes, and so on, they reduce on the effort we are putting in, as we shall see in the successive segments. Then they also change the direction of force. They also change the direction of force. We shall discover some levers change the direction of force, some pulleys change the direction of force, some wheel and axle, like the gears, and those ones change the direction of force. So those are the 3 main ways. Let me repeat them. They increase the speed at which work is done, they make work done faster, they change the direction of force, and they also reduce on the effort applied. Then there are some other terms that we need to be acquainted with as we are dealing with machines. One of them is mechanical advantage. What is mechanical advantage? Mechanical advantage are the number of times a machine simplifies work. Mechanical advantage are the number of times a machine simplifies work. Or we can say it is the ratio of load to effort on a machine. Mechanical advantage, which we shall be using MA. Mechanical advantage is the ratio of load to effort on a machine. That means we shall, in case we want to work out the mechanical advantage of any machine, we shall divide the load by the effort. Other terms we need to be acquainted with is, let's say, velocity ratio. You need to write down those terms. Velocity ratio. Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. Velocity ratio is that ratio of the distance moved by the effort to the distance moved by the load. VR, velocity ratio, is equal to effort distance divided by load distance. VR is equal to ED over LD. Then The other term is work. The other term is work. I defined work earlier on in this segment. I'm defining it again. Work is when the force applied on an object is moved through a distance, or work is the product of force and distance in the direction of the force. How do we calculate work? Work is equal to force times distance. Work, which is measured in joules, the units for work are joules, is equal to force. Force is the units for force are newtons, and the units for distance are meters. Work is equal to force times distance. W is equal to F times D. We have got a number here that I'm going to work out. We are going to see how we calculate work done. A man moves a load of 70 kilograms through a distance of 4 meters. Calculate the work done by the man. Calculate the work done by the man. So, like we said, work is equal to force times distance. The units for work are joules. The units for work are joules. The units for distance are meters. And the units for force are newtons. So work is equal to force times distance. We shall say work is equal to 70 kilograms times 10. Then times the distance, which is 4 meters. Why are we multiplying by 10? We are multiplying by 10 because we have been given the force we have been given is, the load is in kilograms, yet we need to work with it when it is in newtons. So by multiplying it by 10, we are converting it to newtons, then times the distance. So, which is equal to 700 times 10, that is 700 newtons now, times 4 meters. Now it is in newtons after multiplying it by 10. Then which is equal to 2,800 Newton meters. Why? 700 times 4 is 2,800. Newton times meters is Newton meters. But then the units are joules, so we need to convert the Newton meters to joules. We shall say 1 Newton meter is equal to 1 joule. Therefore, 2,800 Newton meters is equal to 2,800 joules. That is the work done. That is the way we shall be calculating the work done. We shall do many more of those numbers when you're back from the COVID-19 break. We have looked at a lot. We got to the introduction by defining these old terms, and then we looked at machines. We defined machines. A machine is a device to which force is applied to simplify work. Then we grouped machines into simple machines and complex machines. We saw examples under each. And then we also discussed ways in which machines simplify work. I'm repeating them the last time. They make work done faster, or they increase the speed at which work is done. Some machines change the direction of force, like some of them, as we shall see in the next segments. And then they also reduce on the effort applied. Listen to the video again and again, because practice makes perfect. Don't forget to share it with a friend. Thank you for watching.